Hello everyone, welcome to the new session of Introduction to Agrometrology. This is the fifth part of this particular session, and in this session we are going to study about humidity, cloudiness, atmospheric pressure, wind velocity and sunshine. So these are some of the small topics we are going to study in the part fifth of this session. So, the first one is humidity. Some water in the form of invisible vapor is intermixed with the air throughout the atmosphere. So, invisible vapor is present in the air. We all know that water vapor is present in the air. Okay, so which is condensed, giving rise to the weather phenomena. And when the condensation of the water vapor which is present in the air takes place, so it gives you some of the weather phenomena, that is cloud, rain, snow, dew and fog. So this part, rain, snow, dew and fog, we have already studied, and formation of clouds also we have studied, right? So this is the part of precipitation. Precipitation part, we have covered all these topics. So there is a limit to how much water vapor the air can hold, and this limit varies with the temperature. So it's very obvious that there is a saturation level that a water vapor can be present in the air, right? And it depends on what? It depends on the temperature. When air contains maximum amount of vapor possible for the particular temperature, that air is said to be saturated. So suppose there is an amount of air, okay, and it can hold a particular maximum amount of water vapor. So when it reaches to that level, right, then we said that the air is saturated with the water vapor. So the water vapor reached to the saturation level. The amount of vapor in air can be measured in the number of ways. Okay. The humidity of packet of air is usually denoted by the mass of vapor contained within it or the pressure that the water vapor exerts. So humidity of packet of air is usually denoted by the mass of vapor contained within it. How much amount of vapor contained within the air. So that is called as the humidity packet. Relative humidity. This is very important. So it is measured by comparing the actual mass of vapor. So at a particular time, suppose this is air, so it can hold an amount A, that is vapor, A amount of vapor, and same amount of air, so B, that hold the maximum amount, that is the saturation level of vapor. Okay. So this is the saturation level, and this is not a saturated. So when we are comparing with it, then this is called as relative humidity. So relative humidity is measured by comparing the actual mass of vapor in the air, okay, to the mass of vapor in saturated air at the same temperature. So in this condition also, the temperature is same as in the case of saturation level. So the temperature is a very important factor that determine the humidity. So we are considering A and B situation, that is B is the saturation level and A is a actual mass of vapor at a particular time. So in both the cases we are taking temperature same, right? When saturated air is cooled, the relative humidity increases as it reaches a temperature at which it is saturated. So this is also very important point, right? Next, Further cooling leads to the condensation of excess water vapor. So we all know that we have studied about the process of condensation, that cooling leads to the condensation of water vapor. The vapor now changes to water droplets. So the temperature at which the condensation set in is called the dew point. So at dew point, the condensation process takes place. The dew point and other measures of the humidity can be calculated from the readings taken by the hygrometer. So this is an instrument used to know about the humidity, to measure the humidity. Next topic is the cloudiness. Cloudiness. So cloudiness, this is simply the state of clouds in the atmosphere in a given time over an area. So how the clouds look out. Okay. So simply the presence of cloud in the sky is called as cloudiness. Different types of cloud means different weather condition. So we know that we have seen that different types of cloud formation takes place in the atmosphere. So this is because different types of weather. For instance, the lighter clouds indicate little or no precipitation, while dark and heavy clouds indicate that there will be a heavy rain or a thunderstorm. According to the World Meteorological Organization WMO, the clouds are classified according to their height and appearance into 10 different categories. We are having 10 different categories, right? So from the height, clouds are grouped into 4 different categories. If we are taking height in consideration, then we are having 4 different categories, and those are denoted as a family. So we are having family A, family B, family C and D. As stated below, there are subcategories in each these main category. So in the family A, we will have a number of subcategories, right? So let us see that one by one. Family A. In this family, there are 3 different types of clouds. The clouds in this category are high. So they are formed at a higher level. The one is the cirrus. In this cloud, ice crystals are present. So they are formed at very high. Okay. So ice crystals are present in these clouds. Look like wispy and feathery, delicate, dazed, white fibrous and silky appearance. So you can see here in the figure also. So sun rays passes through these clouds and sunshine without any shadow. No shadow formation takes place in the case of cirrus. Does not produce precipitation. So these clouds do not produce any precipitation. Next one in this category is the second one is the cirrocumulus. Like cirrus, clouds, ice crystals are present in these clouds also. Okay, look like rippled sand. So here you can see they are like the sand. Okay, and waves of the seashore. So they do not appear like silky as in the case of cirrus, but it looks like ripple sand or the waves of seashore. White globular masses, transparent with no shading effect. Here also no shading effect is there. And mackerel sky, they are also called as the mackerel's sky. So this is about the cirrocumulus type of clouds. Next is cirrostratus. Cirrostratus. Like the above 2 clouds, ice crystals are present in these clouds also. So in the family of A, that bears the 3 different types of clouds, they all bear ice crystals in it. Okay, look like whitish veil and cover the entire sky with the milky white appearance, and they also produces halo. So this is the cirrostratus type of clouds. Okay, now let's talk about the family B. The clouds in this category are middle cloud. They are not very high, but they are middle. The first one is altocumulus. These clouds, ice water is present. Ice water, not ice crystals, whereas ice water is present. In the family A, the ice crystals were present. But in the family B, here in the case of autocumulus, ice water is present. Grayish or bluish globular masses can be seen. Looks like sheep pack and also known as flock clouds or wool packed clouds. So it seems like a flock of sheep. So that is why it is called as flock clouds, or even it looks like a wool packed. Okay, so that is why it is called as wool packed clouds. Next, altostratus. Altostratus. In these clouds, water and ice are present separately. Looks like fibrous veil or sheet and gray or bluish in color. So you can see the sheet-like appearance. Okay, sheet-like appearance of the clouds, and it produces coronos and cast shadow. It casts shadow. This is the first cloud here. We can see that it casts shadow. Rain occur in the middle and high latitude. So it brings rain here. Now comes the family C. The clouds in this category are lower clouds and they have three subcategories. So they are called lower clouds. So family A, that present at very high level, family B is present at the middle level, and family C, it present at the lower level, and it is having three subcategories of the cloud. The first one is stratocumulus. These clouds are composed of water, so it do not have ice crystals. It is having water in it. Looks soft and gray, large globular masses and darker than altocumulus. It is quite darker than altocumulus. Okay, long parallel rolls pushed together or a broken masses like appearance can be seen in the stratocumulus. The air is smooth above these clouds, but strong updraft occur below. So air above these clouds are smooth, right? Smooth air. But it is very strong below these clouds. It is very strong. Okay. So this is the peculiarity of this particular cloud. Next one, second in the family C is the stratus. These clouds are also composed of water. Look like for these clouds resemble grayish white sheet covering the entire clouds. Okay, entire portion of the sky cloud near the ground, and they are lower level, so they are somewhat at the near to the ground. Mainly seen in winter season, and occasional drizzle occur. So they bring a drizzling effect of the rain, right? So this is the peculiarity of the stratus type of cloud. Nimbostratus, third type in the family C is the nimbostratus. These clouds are composed of water or ice crystals. Look like dark gray uniform layer which reduces the daylight effectivity. Okay, so they reduces the daylight effectively. So when the sunshine is there and when the clouds come, the visibility lower down because it casts the do not allow the sunlight to pass through it. So daylight effectively is reduces. Give steady precipitation. It brings about the precipitation. Sometimes look like irregular, broken and shapeless sheet-like appearance of this clouds. So nimbostratus brings about the precipitation. Okay, now the fourth category of the cloud is the family D. So these clouds form due to the vertical development, that is due to the convection currents. Okay, so two subcategories are present, that is cumulus These clouds are composed of water with white majestic appearance with the flat base. So here you can see white, totally white appearance of the clouds over here, right? And they are formed due to the convection current of the water vapor present in the atmosphere. So irregular, dome shaped and looks like the cauliflower. Very good. Looks like the cauliflower appearance, and wool pack and dark appearance below due to the shadow, right? So we can see the shadow of such clouds. These clouds usually develop into the cumulonimbus clouds with flat base. Okay. So the next category in this family, that is the cumulonimbus. So the upper level of these clouds possesses ice and water is present at the lower level. So here at the upper level, ice is present, and at the lower level, water is present, right? So these clouds have a thunderhead while towering and will top and develop vertically. These clouds produces violent winds, thunderstorms, hails, lightning during the summer season. Okay, so this is all about the different types of clouds. Next topic is the atmospheric pressure. Atmospheric pressure is the weight of air in the atmosphere. So how much weight is applied by the air in the atmosphere, that gives you atmospheric pressure. So changes in the atmospheric pressure are mostly caused by the rise of warm air and the descent of cloud air hence. So atmospheric pressure occurs mostly near the water bodies. So water vapor is a very important factor that affect the atmospheric pressure. So we can see the atmospheric pressure occur mostly in the regions near the water bodies, because where there is water bodies, there occurs the water vapor. Okay, so that water vapor becomes a part of the air. Now that exert a pressure which is called as atmospheric pressure. For instance, the coastal region and islands on a daily basis experience severe storms as results near to the water bodies. So how this storms or these how these coastal regions and the islands on a daily basis experience these severe storms? This is just because of the atmospheric pressure. Okay. Wind velocity. The air is near always in motion, and this is felt as a wind. Two factors are necessary to specify wind, that is speed and its direction. The direction of wind is expressed as the point of the compass and where the wind is blowing. So we can, with the help of compass, we can know the direction of the wind. Wind velocity. Air moving from the northeast to the southwest is called as the northeast wind, and the northeast wind would be 45 while southwest wind will be 235 degrees. The wind speed can be expressed in miles or the kilometers. So these are the units. These are the different units in which the wind speed is expressed. So it is expressed in the miles, it is expressed in the kilometer per hour, it is expressed in the meter per second, knots, or as a force on the Beaufort scale. So this is a instrument that is used to measure the different units of the wind speed. So knots or as a force on the Beaufort scale is measured. The last topic is the sunshine. Many weather stations record the amount of a bright sunshine during the daylight hours. So meteorological department, they are having the weather stations, so that record the amount of the bright sunlight during the daylight hours. A typical measuring instrument that is called as the Campbell's Stokes sunshine recorder, which is consist of a glass ball which focuses on the sun's rays. Burning hole is an index card. Okay, so this instrument is a very important to note down, or the instrument that note down the how much amount of sunshine is coming. Okay, so Campbell Stoke is that instrument. As the sun moves around the sky, so burnt hole extend along the index, which is marked in hours to record the amount of the direct sunshine. So as the sun moves around the sky, sun is not stationary, it is continuously moving. So the burnt hole extend along the index, which marked in hours. Okay, it is noted down in hours to record the amount of direct sunlight we are receiving. Okay, so this is all about this session. We will meet with one more interesting session of this particular topic. Okay, till then, thank you very much.